So welcome everyone to the April 17th, 2017 Kubernetes SIG Apps. My name is Matt Farina, and we may or may not have Michelle today. We'll have to wait and see. So today, let me start by sharing where we can record any minutes or discussion, and actually has what we're going to talk about today. So I'll share that into chat for anybody who wants to follow along and take notes. You'll see that this week we are a little light on some of the organized topics, which is really going to give us a good opportunity to dig into one of the topics on here, which is the update API comparisons for deployments, things like that. And so we'll get into that in a minute. Two quick announcements. One, do you have demo suggestions? Anybody have something they want to demo, or maybe something you would like us to track down because you got something cool and neat you would like to see us have demo here, but maybe it's not yours? If you've got something, please let us know. Reach out on the list or reach out to Michelle and myself. We would really appreciate knowing anything else that's out there. We've got some ideas. We do have some stuff lined up, but since we do so many demos here, we're always looking for more. And so please reach out if you've got something. Even if it's just a feature on something that exists already and you want to show something new and shiny off, please do so. Then the other announcement I have is if you go to the mailing list for SIG Apps, you'll see there's a conversation about Kubernetes examples and what they want to do with that. That really does hit home here because it's user example documentation. And there's a discussion around finding a good path forward for handling that. Some of the stuff in the examples directory as it is today is stale, outdated, not tested, and they're trying to figure out who and what's the best road to handle cleaning that up to give a better experience for the end users coming in. A lot of the content there predates Helm and a whole bunch of the stuff we have today, and so we need to figure that out. So if you're interested in examples and things like that, please head over to the mailing list and jump into the conversation or see if there's something you can do to help. Those are the two announcements I have. Does anybody have anything else that should be brought up? All right, then we have our main topic here. And are the folks on who can talk about this? Let's see. Yep. So the main topic is our discussion point of the deployments, updates for stateful sets, things like that. There's a document here, and I will drop it into the text here. And since this is for deployments, daemon sets, stateful sets, and updates, this isn't my cup of tea. Who is here who wants to walk us through this? Is anybody on? Can you all hear me?
Yep. So,
yes.
Hey, Janet, do you want to take this over?
Yeah.
Okay.
All right, where would you like to begin?
I can share my screen.
Please, the floor is yours.
Can you all see my screen?
Yep.
Okay. So I want to talk about how we handle the rolling update of the main controllers, which is deployment, daemon set, stateful set. And we have two main solutions now. One is using hash of the template. The other one is using template generation. And right now, deployment is using the hash of template to do the rolling update. So the hash value is used to create for uniquify the replica set that's being created. And replica set is like the deployment history for you to roll back, or and also the replica set is used to create pods. And I should probably paste this link to the I don't know how to. Anyway, you can get this document from the
That link, it was the second link in chat. They should be able to click on it now.
Okay. And the template generation is also used. We plan to use it as a similar way, like using it to uniquify the sub-resources created for history. And right now, daemon set is using template generation to differentiate different parts of different revision, but daemon set and stateful set doesn't have any history implemented yet. So that's the general idea. So to dive in more, the reason why we need this discussion is that right now deployment has a hash collision issue because it uses the Adler to compute the hash, and we have a customer reported issue that it has collision. It's not as stable as other hash functions like F and V. So we are proposing to switch to other hash functions. And so for using hash, the deployment can just switch to a more stable hash algorithm. And then if we just switch, then we need to migrate because the old hash value might conflict with the new hash value. So we need a migration step. Or we can just append some suffix when there's hash collision. If we do this, we don't need to migrate. So the value can be a timestamp or a incrementing number like 1, 2, 3, or a random string. But there's some, so if we choose these three, then.
So let me ask this real quick. When it comes to adding a suffix to it, like this, how, if you had to come back and recalculate this, how would you be able to get to that same number, such as 1, 2, 3, or the same random string or timestamp?
So I think this. So if I just use the so the value is only used for uniquify, not for comparing things or figuring out which template match each other.
Okay.
But you have on the con.
Can you repeat that?
You basically have identified the con that's listed there about idempotence.
Ah, okay. Yeah, sorry.
Yeah, so the idempotent part is because the deployment controller use cache. So there's a chance that it create a replica set but hasn't seen it, and then it may create more than one replica set with the same template. And we have this issue in replica set and replication controller. When they create pods, the pods have random names, so they may create more than they needed, even though they will eventually become what's specified in the spec. But there's this issue. Does it make sense?
Yeah.
So this is easy to implement, but this has this issue. So another way to avoid hash collision is to just use a new field in deployment, and the field is called uniquifier, and it will only change when there's hash collision. So we use this uniquifier value with the template to compute the hash. so we can avoid hash collision with this field. And so when the deployment failed to create a replica set, it's either because of name conflict, then it will just increase the unifier, and then the next time it will create a new hash value. Or if it's not due to name conflict, then it will just retry again with the same unifier, so the hash value will be the same. Or it's not either. It's because you already create a replica set with the same name, and the template is the same as the one that you want. So you just haven't observed this change in the cache, so you can just say you're done because this is the replica set you want. So that's for deployment hash. So basically we want to switch to a more stable hash algorithm, and we either migrate or we use another way to avoid hash collision.
Okay.
So for daemon set, it will be very similar to what we have in deployment. We use the hash value to create pod template. Use it as the pod template name and the pod template labels. And you also use that to label your pods. But the problem is that we right now use template generation in daemon set pods. So we'll need to deprecate template generation if we want to switch to pod.
So for those who are not familiar with template generation, it's just an incremental counter every time a user updates the port template of daemon set. There is this template generation that is increased. And based on that, we are planning on having history of port templates or whatever resource we pick for history. The name will be created by the template generation. And that's what the template generation proposal is about.
Yeah, so template generation is a number starting from 1. And every time the template is updated, the API server will increase the number by 1. So only the server can update it. Users cannot change this value. So if we use template generation for history, it should be unique unless users create a template generation with the same name or they forgot to clean up previous history.
Okay.
So the stateful set, if we use template hash, it will be similar to daemon set and also the deployment current implementation. But we need to know that stateful set doesn't have the template generation implemented yet today. So if we can use either. There's no need to deprecate. And for template generation, if we want to use template generation for deployment, then we need to deprecate the hash, template hash. And we also need to figure out how to adopt existing replica set from previous release. So the idea is that for the replica set created in the new release, we just name it as, we suffix it as with the template generation. And for the old replica set, we just relabel it with the replica set name. So it's guaranteed to be unique because you already have it. And so the good thing is that we will not have hash collision issue for template generation. But the replica set names will be very different. And will that confuse users? And also template generation has a similar meaning in name with revision, and will it confuse users? Like which one is the real, which one means the real version?
Yeah, I think we should document this, that template generation is something that it comes from the API server, whereas a revision is what the controller observes as the next thing that needs to run, right?
Yeah, and that's my main concern about the template generation approach is confusion with the revision. So after a rollback, template generation will increase, but the replica set that's actually used, or whichever controller we're talking about, the name of that resource and the labels are going to be the old template, match the old template generation, not the new template generation or revision.
Yeah.
So with a hash, there is no such confusion because it just looks like something that's not supposed to matter, which in fact is what this is supposed to be. It's just supposed to be something that's not supposed to matter. It's not something that's supposed to be used for matching or anything else. It is just a unification mechanism, and the hash makes that more obvious. And over time, we can converge the approaches for all the controllers, including replica sets and how they create pods, to move to a more deterministic but similar looking mechanism. Like we can, make them all same in terms of format and in how they're generated. Whereas with template generation, I think there's pretty much no hope of that for replica sets in particular.
So the discussion for stateful set, at least at this point for upgrade, is actually along the lines of when the template generation increases, the controller has to detect the equivalence between the new template and previous revisions of its history, and then relabel its children in order to make them match the appropriate current template generation. So,
yes, but that is very tricky if that is used as a selection mechanism. And it is impossible if it's the name of the resource. Like you can't rename the resource. You can delete it and recreate it, but I'm not sure that that's better.
Yeah.
And we're not, so for template generation for stateful set, the idea was to embed the template generation as a label on the pod itself. So you could relabel it, but it wasn't meant to be selectable. It was meant to as an identifier. Like effectively you're using it as a label and you could select on it, but it's no different from an annotation in terms of how it's actually being used.
For the other controllers, that is not the case.
So you're selecting on template or you would be selecting on template generation?
Yes, because it effectively serves as a unifier for the label selector.
I see, okay.
No, I think in deployments we would still continue using deep equality, right? And pick the new replica set based on deep equality. The name of replica set shouldn't really matter because it's something that is controlled by deployment, and users, all they need to know is I have this deployment and I don't care about anything else.
That's mostly true, although I think people will want to be able to see things like, are the pods of this particular revision behaving correctly or not? In which case it's useful to be able to have some sort of identifier that they can understand in terms of some concepts. So I think we will want to consider perhaps labeling pods with revision, but not selecting on that. But we do need a unifier for selection, and I agree that unifier should serve no other purpose other than just as a unifier for the resource name and for the label selector. And that's the goal with the hash-based approach.
Agree.
So if it's not clear, my suggestion is we go with the hash-based approach plus the collision avoidance mechanism, and we try to gradually move all of our controllers to that approach.
Is the reason for the collision avoidance mechanism because the hash algorithm we're using is too weak and we would prefer to change to a different hash algorithm?
Well, we are going to change to a different hash algorithm, but fundamentally we have issues like different information gets included in the hash depending on what fields are available in the resources. You know, and I don't know how much entropy there is in the resources anyway, and whether a hash will always work. But
Brian, I think a hash will almost always work, Brian.
Almost always.
So assuming 10 deployments per namespace and 10 history items per deployment, the probability of collision with a good 32-bit hash should be about 1 in a million. So I think we can accept 1 in a million failures per namespace.
But adding the collision avoidance mechanism as a field in status, I don't think significantly complicates the mechanism in any way and avoids problems with changes of implementation or other sorts of changes that could cause collisions other than just pure random bad luck.
So,
okay.
Brian, you bring up an interesting point on the changes algorithm. Have we looked at something where today, I haven't looked at how we store it. Do we actually store the algorithm, to signify it, and then like the separator, like a colon, and then the hash, or just the hash itself?
So the hash is used in the name of the replica sets that we store in etcd. The problem with the current hash algorithm is that it's really weak. It breaks really fast, and CI systems that have deploy lots of replica sets, they can really easily collide. And that's what a couple of users had problems with.
And so this is our hash algorithm, and then CI/CD doing so much work that we actually get to those 1 in a million cases because of the hash algorithm.
Actually, with Adler, they are much quicker. It's like in 200 replica sets.
Adler is just a terrible hash. We should
Yeah.
have never picked it. It was an accident, and now we're paying the consequences of it.
But we do still have challenges like the sets of values we're hashing on can change over time, and other things we change in the system can potentially cause collisions to be more likely.
Yeah, that's the other problem.
Information,
Yeah,
right? So just adding the collision avoidance mechanism, I think it's not much work, and it can be a status field that users don't have to care about at all, and it will make it robust against these kinds of, I don't think we need to do any work to migrate the pre-existing replica sets generated by deployments and currently running clusters if we add this collision avoidance mechanism, because it will just skip over any of the names, even if we decide to use a hash in the same format, which maybe we shouldn't do. But I think there are a lot of benefits robustness-wise to adding the avoidance mechanism to just make this not a crisis the next time we say, oh, we didn't think about this case.
Yeah.
So both solutions can work, but I would like to, if we are going to have to continue with hashing, let's have both stateful sets and daemon sets, and the APIs be the same. So it's going to be less cognitive load for users.
Wait, here's the only thing. For stateful set, you're not, when it's creating a new pod, the name of the pod, there's no hash in the name of the pod, right? The name of the pod has to be determined.
Where this would be relevant, Ken, is for the history of the state.
So you want to
not
generate
the pod names.
Well, the only issue, so do we ever want the user to be able to view the history corresponding to a particular revision they made? because with the template generation ID, right? Like if the way I'm proposing to concatenate the name together via the stateful set name and the generation allows a user to view a stateful set pod template as part of the history by just saying, I want this pod template with this name at this generation. Right?
So what we had said was that we want to, I think in the long run is that we think there should be additional systems outside that help make history, like real history of an object, more of a generic problem. And that we should have an affordance that transforms that history on the server side. But I don't know that we have to, like, I don't know that the client should necessarily start hard coding that assumption.
Well, so the other thing about that is the point I made before, which is template generation is going to monotonically increase. What happens when you do a rollback?
Yeah. Rollback is, it is better for an end user for template generation to go forward rather than back, for sure.
So the rollback would look like the template generation goes forward, and then you relabel for staples. You relabel the pods that had the previous equivalent template to have the new template generation as their label. So they're selectable by the new template generation, and the template generation is consistent with the current template of the stateful set. But
you're going to generate a new pod template with that name, or you're only going to use the old one that has a different template generation?
You're going to have to generate a new template generation with that name and then relabel in order to make it equivalent with the current. If the important thing is that
so that's way more complicated for the other controllers that have running pods associated with the template.
Well, no, I'm not going to create a new pod. I'm going to create a new pod template, right?
But I'm saying for the deployment, which is using replica sets,
right,
that approach is much harder.
Yeah, I will say though that it's fair that the replica set and deployments is a complex mechanism. We don't have a ton of controllers driving controllers today, and if we did have controllers driving controllers like federated, like federation stateful sets are going to have the same problem when they map down from stateful sets in a federation down to stateful sets in the cluster, depending on how that design proceeds. Like, it's going to be harder. We should make sure that within the stateful set itself that it manages the templates reasonably. Like, I don't think we can assume that the way that templates are managed for a stateful set can necessarily be used by a higher level controller.
Correct. Yeah. But so, and then that's another question with this entire approach. So for stateful set, currently using pod templates as a method of storing history is a proposal. Do we have actual concurrence that that's what we want to do? Or would we consider using a sub-resource inside of the status, for instance, or spec, or an entirely separate sub-resource or another object? Because those are
it can't be a sub-resource. So in the initial design discussion on this, it can't be a sub-resource because there's too much data to store. It would mean we would effectively divide the size of a reasonable pod template by a third. So I would say, to keep the current, the next, and the previous. So I think we have to deal with a separate object. We can certainly transform a separate object as a sub-resource, as in the history sub-resource proposal. Whether it's a pod template or not, I think is do we want a generic thing that everybody reuses and do we get a benefit from it? Or do we want a separate thing for each resource type that, while it isn't generic, solves each individual's problem more effectively?
So if we do a separate resource as basically a reference sub-resource inside of the spec, right? A separate object as a reference sub-resource inside of a stateful set, per se. You get the uniqueness benefit, right? So I'm not going to have collisions between daemon sets and stateful sets in the same namespace with the same name in terms of their history if we take similar approaches. And I mean, in terms of making it more complicated or less complicated than pod template, I don't think there's any extra complication there. The other nice thing is maybe because it's all being controlled inside of the controller, I don't have these pod templates that I have to relabel or rename or hash. Right, I have a collection of objects that I'm in control of and that I can commit atomically in a single transaction. Maybe it doesn't become as much of a problem in terms of incrementing the template generation. Like maybe it's a lot easier to get rid of that.
So for things that aren't deployments, which have to manage controllers that themselves are stateful objects, I think there's a reasonable statement that we could make that the whole point of a stateful set is to give you a target that you can update, and then the system brings it into convergence as much as possible. The history is primarily there so that a user can identify and roll back to a previous state easily. Is there, and Brian, I don't know, like we haven't talked about this in a long time, but that's my bias towards the point of the stored historical revision.
I don't think anyone's disputing that. At least I haven't seen any comments to the effect that that's the primary use case.
And we had intended pod template for a different purpose. And I think that we're at the point where we're trying to decide between whether we give up on the original purpose of pod template, which was to keep controllers from being able to create any object in the system just by being able to run a pod, like to be able to take over the system, because a controller that can create pods is probably the most powerful thing in the universe right now.
Yeah, we actually have more reasons now for pod template. For example, to make it easier to build common tooling that works for third-party controllers and things like that.
And I think the challenge with pod template for stateful sets is brought up the moment we start talking about volume claim templates. And I'm not positive, but I feel somewhat confident in saying, if I update a stateful set and change the volume claim template and totally blow away my stateful sets, config so that the new stateful set doesn't work, I kind of want to be able to roll back to the previous version of both my volume claim templates and all that. Whether that's, whether we include it, but I do feel like there's at least some hedge that I would make that a pod template isn't enough for stateful sets.
So, I mean, in thinking through that, particularly for volume claims template, there are not a lot of things you could actually mutate on it, right? I mean, what does changing storage class mean? That's just a scary idea to me. Like, what would the semantics of that be for the end user? And then if you're going to be changing the storage capacity, I'm assuming you probably would only ever want to increase it, and decreasing it is fairly unsafe. And then if you mutate it to increase the size of the volume claims for the stateful set, shrinking it back down is probably not super safe either. So I'm not really sure there's a lot of configurable parameters that people, even if we were to implement the ability to update a
the example I can think of are spreading selectors for the cluster. So that's probably one that today you would have to delete and recreate, and you'd be fundamentally imbalanced. So maybe that's okay.
Well, so actually I want to expand on the delete and recreate point a little bit, since we're getting kind of off the original topic about template generation. Another thing I do want to be able to do is enable users to delete and recreate a resource as an escape hatch that has come up many, many times. For example, when we make incompatible changes to resources, or we change their names, like that set to stateful set, or basically for every single one of the controllers we've been developing post V1 API, there have been cases where it's been useful to be able to delete and recreate. And there are still examples of that for services, or if you want to do some out-of-band orchestration and not have the controller fight with you, it's a useful thing, since we don't have a way of freezing the controllers generally yet. So I want to preserve that ability. So if we did use template generation, I would want a way to be able to auto-detect what template generation should be used. We have something like that for revision, where it looks around and to see what the current, the latest in use revision is, and then sets one higher. I would want a similar mechanism for template generation.
Yeah. Okay. So I didn't want to, so just rewinding back, I mean, the argument, I think, for everything that's not a deployment is that the history object is mostly for communication and for the controller to have some atomic record that it can use in the absence of a more general, multi-revision store of stateful sets. So we should bias towards that, and then we should assume in the future that there will be a generic history mechanism for people who want to go back and reconstruct full versioned history. But that's
actually, there's a stronger reason, which is, and maybe you think this is different for replica set versus pod template, but I don't think of it as different, which is, if you're doing any kind of rolling update, you need multiple versions of the configuration live at the same time.
Yeah.
And you need some way of managing the life cycles of those resources. For example, if your pod template has references to persistent volume claims or config maps or secrets or whatever it is, you need those resources to stay alive as long as the pods that are consuming them, or as long as you want to roll back to a template and create pods using that same configuration again. So,
but isn't the right way to do that via owner refs and garbage collection?
So
exactly, but what I've been planning to do is hang those owner refs off of the replica sets or templates,
yeah.
pod templates.
Yeah, and whether the history is a pod template or a stateful set history or stateful set pod template or a stateful set historical revision or a stateful set revision or whatever it is, you're right. We want to hang references off those, and the objects that exist in the system need to form that referential set.
Yeah. But I guess my main point about this is that it can't be some funky kind of history that requires a different API to look it up. It actually has to be in the form of the actual API resources so that other components like Kubelet can consume them still because they're still needed.
So yeah, so there has to be an object. It does not have to be pod template. Brian, you made the case that pod template in its initial purpose is more important than it used to be, because we are now starting to reach the boundaries of where that security inversion becomes very dangerous, and as well as the tooling coordination.
Yeah, like kube control set, for example.
Exactly.
So then, okay, for stateful set, if we move toward the idea that we have this object and the object could be referenced as a sub-resource but created separately, and that stores all of the history, and we're already going to have to do strong equality, like deep equality testing to determine if the pod template matches anything inside of the history, then do we even need a template generation? Like, is that even a necessary thing anymore?
You need unique name.
Right, we need a uniqueifier, and we need two things. For creating the actual resources, we need a uniqueifier.
No,
And for managing the history, we need a revision.
Right. Well, but so for stateful set, I don't need the uniqueifier. I have an implicit uniqueifier given the way that I'm generating pods.
It's not about the pods, it's about the history. This would be uniqueifying the names of the templates, not the names of the pods.
If we don't use pod templates, if we have this object that aggregates history that's stored as a sub-resource, I don't have the issue.
It cannot be a single resource. I'm just telling you, I'm mandating it. It cannot be a single resource. Single resources have a bounded size, and history is going to someday expand over
type, a separate resource type per controller type. Is that where you were going, Ken, or no?
Yeah.
Yeah.
No,
So
that doesn't make any difference because you're still going to have multiple resources, each of which needs a name.
Okay, you're right. Yeah. So there has to be something on that object to uniqueify it. But the name has to be unique. You're right.
I think the bar for separate resources is quite high because every resource we add adds a lot of complexity to the system. So I haven't heard an argument for why we would need a different resource for every controller. And
I mean, the argument is stateful sets is it's not enough to just preserve the pod template. That would be that's the most concrete argument, I think.
It's not enough for deployment either. I mean, you also need to preserve the constellation of config maps and secrets and whatnot.
Yeah, but those are external references already. I think the volume claim template is the only thing it is the only novel thing in this whole system that's not just a pure template cloner.
If we don't do it by type, the other thing is doing it by kind gives us uniqueness by kind. Otherwise, you can have potential collisions in the revision history of, say, daemon set and stateful set, where they both use the same object type to store their history, right?
So I really think you're narrowing our options by forbidding us to use the same object, Brian. So maybe you should lay out your reasoning there a little bit more detail.
Well, so first of all, there's the issue that Clayton mentioned, which is the pod templates themselves today are big and they continue to get bigger, and I foresee them continuing to get bigger. And resources are a bounded size. And second, it is going to prevent you from providing flexibility in terms of how much history is preserved, because it is a bounded size.
But it could be stored as a delta rather than a complete copy of the old pod template.
It's still going to be the case that you will have less flexibility in terms of how much history you are allowed to preserve. There's going to be some limit, which is totally unpredictable, especially if we're storing deltas, for how many can be stored.
Yeah.
I don't.
Go ahead, Eric.
The size of a delta is going to be very small compared to the total size. So I think it's going to be, you're typically going to be able to hold 10 and you don't need more than 10.
I mean, I will say that the order of deltas, so typically the vast majority of changes are small. However, I mean, to Brian's point, yeah, I mean, assuming the existence of an external system that can store infinite deltas and infinite history, it becomes less of an issue to have those be live, because if you have 30 live things holding references, you have another problem, which is I don't know that we would design deployments or stateful sets to hold 30 live revisions. So there's some level there that we could potentially look at, but the delta does get very ugly very fast. Like now we have to go invent a JSON delta format.
I also am just very concerned about the predictability. Like, can we pick a reasonable number that we can guarantee that for the foreseeable future, we will not overflow the size of a single resource?
I mean, certainly people are starting to put very large environment variables into pod templates, which might be nested config, and it's a very reasonable use of the system. I mean, it's certainly, the risk is there, Eric, that even a small change, we can't do subfield deltas efficiently enough to not break somebody who has something deployed today.
But that just tells me that we need to define a limit on the pod template size as opposed to defining a limit on the total object size, and then adjust our total object size limit as a function of that.
A 32K a 32K environment variable stored as a config, like an inline config, is a very reasonable way to use the system today. 32K is like right at the bounds of, like, you change that 3 or 4 times and you're starting to push up against, like, that's going to cause significant problems in the rest of the system.
So we have some limits today, not enough limits for sure, which is going to be hard to fix, but we have some limits today, but they're designed for pods or pod templates to just have one per etcd key. Changing those limits breaks backward compatibility. At some point, we may need to impose new limits and break backward compatibility, but it's going to be painful.
Yeah, I mean, like, the de-unification, like, it is annoying. It is not insoluble, but the problem is it's unstable with regards to unanticipated changes in the system, which we've already demonstrated several times. So is it worth it for us to build the correct de-unification the first time and say, do we believe that we can anticipate all future changes based on our current experience over the last 2-3 years on this?
The de-unification, I don't have no doubt we can do reasonably. It's the issues around what kind we use to store stuff, whether it's one or many permissions, proliferation of kinds, and proliferation of objects. That's the concerning part. The hash thing we can sort out.
So it's interesting because I think about something like the etcd operator, which doesn't look like a pod template at all. And we're not seeing an explosion of the number, or I don't anticipate an explosion in the number of controllers that recreate pods in the near term. It probably is much more domain-specific third-party resources, Elasticsearch, Prometheus, the Alert Manager, et cetera, et cetera. The number of operators people are starting to create, those tend to be much more specific type resources. Do we believe that we need a solution that assists them as well, or would they use the unification?
Well, like Elasticsearch doesn't create pods directly; it creates stateful sets and deployments. And I expect to see a lot more operators, not all, but many operators that are going to create our generic things and use them.
But
that means that, like, we're now going to have like a stateful set template and a deployment template and a daemon set template problem. So I think we should make sure that we don't just focus on the fact that, we have a pod template object we're all itching to use, and pods are the main thing. Like, there's going to be other objects that get updated.
I think the daemon set and stateful set work. Like, so let's say I want to build an HDFS operator. Stateful set and daemon set are the primitives that I should be using in order to build that operator. If the higher level operators can't use stateful set as a primitive to build their stateful applications, then I feel like we're not doing something right. I feel like if everybody's working around stateful set and doing something custom, then we haven't hit that target, that sweet spot where we've covered a large number of applications with it.
Yeah, I would agree. I've mostly been probing that angle for would the etcd operator hypothetically need to use, what are the things that it would need to do to properly handle rollbacks? Would it need to read the limited sub-resource for history on the stateful set, or would it need to touch the raw objects? Would it need its own deunification if it also needed to hold on to garbage references, etc.?
So it's not even clear to me that it would necessarily surface, like, I don't think that Elasticsearch operator surfaces the pod templates for the individual parts to users.
Yeah.
I think they can just, there's a select subset of fields they can set. So it's almost a different problem there that needs to be solved for history for that thing.
Okay.
So they're gonna have to solve the, like, here's the 5 fields I let you change. Let me have a history of those values, or maybe I'm not gonna do rollback.
I would hope that for stateful set and daemon set, but to go back to the HDFS as a reference, that if I'm updating my data nodes, I'm performing a configuration update on the daemon set of data nodes that are in my cluster. And that rollout, that configuration change, or that if it's bits moving as well, that binary update is going to be handled by the daemon set itself. And same if I'm going to upgrade the configuration on my name nodes, or if I'm using journal nodes for a quorum journal, those stateful sets would handle the configuration for me. So as the operator, I'm more concerned with encoding application-specific logic and application consist. So, like, to put it for an example, if I was actually going to do an update for HDFS, I'd have to do one update to the name nodes to begin with, do periodic iterative updates to the daemon set to update the data nodes, and then do another update to the name nodes to finalize that upgrade for HDFS, right? And doing the same thing, like if I was going to try to do Yarn or something like that, it's the same deal. I have multiple updates that constitute one application-wide actual update. And that, I feel, is like the domain of the operator. But we need to provide the operator with the right primitive so it can do that easily.
Well, and declarative configuration update on the stateful set and the daemon set with annotations is a way to record. We know that works. We know that reinforces all of our other patterns. And so if the historical details basically come down to, I guess, can we make a reasonable limitation of what the goal of the template is to keep it constrained enough that we can, Brian, I can't tell whether you want it to be as generic as possible so that we don't create too many of them, or whether you want it to be generic as possible because you think there's an underlying use for a, not quite a pod template, but a controller history reference generic object.
I have to think about that a little bit more.
Because if we stop saying the word pod template and started saying historical controller state or historical controller template, is there a generic historic controller template independent of what a pod template looks like?
Yeah, I would be fine with that, I think.
Because we could certainly abuse annotations on that for controllers that needed, or add things to a historical controller reference, like deltas for things that aren't directly captured. Like, say the historical controller reference included a pod template, hypothetically. We could certainly leave affordances for future addition of things like a volume claim template delta that's only the information that the stateful set needs to reconstruct. We could put template generation on that. We could add additional things without necessarily abusing pod template. I don't have a strong case for stateful set, as Ken pointed out. Like, I don't have a strong case for stateful set needing volume claim templates. I know that stateful sets are tied to their data. Their data is tied to labels. Labels are going to be live on both the set and all that. Even if we have delete and recreate, there's going to be some level of, we may need to track that, and I don't want to leave it off in the future.
So the main argument against pod templates for stateful set is that it doesn't solve the problem of persistent volume claim templates, or that they're too big, or...
My primary argument against pod template is that it's not what pod templates were originally intended for. I think the alternative thing that we have not resolved is a stateful set template like all the other controller type templates, and volume claims are the only thing that are different between them. with the possible exception of things like strategy, which we might actually at some point in the future want to put onto the historical reference.
So I have a question. When users say they want to roll back, do they mean I want to roll back to a previous pod template, or do they mean I want to undo the last operation I did to this object to whatever fields they were, and maybe it just happens that the pod template is currently the only thing that's updatable on the object, but there might be fields in the non-template spec that are updatable in the future.
So
and we end up storing the non-pod template spec fields as a history as well.
That's an excellent question. I think Clayton just mentioned the rollout strategy potentially being one. I don't necessarily know that we need to solve that problem, first of all. I still expect users who want full rollback capability to just store their configs in version control and roll back that way. And as I was saying, I'm using the actual resources that are going to be used by the system as part of the history. Is necessary when we have multiple versions in flight. For example, the config maps and secrets and so on need to be alive. It's needed for the lifecycle management of those resources. In the case of the replica sets generated by deployment, it's needed because they're actually managing live pods. But for general rollback of other properties, I don't necessarily know that we need to solve that problem. And there is at least one case where I believe in general, we don't want to roll it back, which is the replica count in deployment, for example, which people often want to control operationally independent of other rollouts, or may even be controlled by an autoscaler, which hopefully will become a very typical case, or at least a frequent case in the future. So that's deliberately not rolled back when someone says rollback.
A concrete example of something. So this is kind of like, this is stuff that in OpenShift deployment configs, because we added hooks, and hooks roughly look something like a very small pod template, but the end state of a hook is, well, why can't I do all the things I can do in pods? Because a hook is really just a simplified job. There was some overlap there that I'd like to avoid making that same mistake twice. Like, for the same reason that pod templates can't grow in the same object, you can't have like 3 copies. It becomes very difficult to justify a hook on a deployment that has 3 copies of a pod template that are different. So I think we should probably try to avoid having more things outside of the pod template that aren't related to what it does, and we should look for a higher level concept to track those, whether that's applying config or something like Jenkins or whatever, doing declarative jobs.
So we said that serious heavy-duty users should store their config in revision control and have the rollback happen at the revision control level. We also said that we can't have the state history stored in the object because those are users who have very large environment variables, and that they require a predictable level of number of rollbacks. Are we sure that is it possible that those are already handled by the same case, in the sense that are the people that have the big environment variables and the people that need predictable rollbacks, are they also the people that should be using Git? And we can just focus on the casual or introductory user with the built-in history?
Well, so another reason for the history is it can be the number of different versions currently in flight. Maybe that's not an issue with stateful sets, but with deployment, I definitely want it to be the case that I can have, if I have a deployment of 1,000 pods, I can have 10 rollouts in flight. Like, I can just keep pushing changes, and I don't have to worry about the case that, oh, a rollout's already in flight, so I can't actually push another change.
Yeah. Hey, folks. We've got 3 minutes left in SIG Apps, and so I'm just doing a time check here. I see that this is a very hearty conversation going on, and so I feel bad jumping in and calling time on this. So I just want to ask, what's the next step that we should take here to continue handling this, to either tie off or continue conversations or whatnot, because we're coming to a close.
We need another hour with interested parties to do this again.
Yeah.
Do we want to do this here in SIG Apps, or did the interested parties want to go off separate from here and do it?
I think we should do a separate meeting and then just invite people, invite the SIG and invite the others who are stakeholders.
Sounds great. Who wants to take owning the action to organize that meeting?
I can do it.
Fantastic. Thank you. So if you want to be invited to that, please email the list, SIG Apps list, and ask just to make sure that anybody who wants to be there is known, and anyone else, please reach out and say, hey, I'm interested, if you're interested and haven't already been part of this conversation. All right. Is there anything else we should do in the last minute? All right, folks. Fantastic. Thank you for, I wasn't sure, I actually put time in for open conversation. I figured we'd get through this one pretty quick. It turned out to be a much more interesting conversation than I had anticipated. So thanks, everyone.
Thank you.
And have a wonderful week if I don't talk to you before.
Bye.
Bye.
Bye.